All right, for this next example, we're going to look at a polynomial inequality. And remember, with polynomial inequalities, we need to find the x-intercepts to make our sign chart. Okay, so find x-intercepts. That's the first thing. And then the second thing is to use a sign chart. Okay, so those are the main two things we're going to need to do here. So let's set up first example, x cubed minus 2x squared minus 4x is less than or equal to negative 8. Again, it's a polynomial inequality. The problem with this one is we don't have a 0 on one side. We need a 0 because when we solve these polynomial inequalities, we need to compare the polynomial with the x-intercept, or the x-axis. Okay, the x-axis is at 0, so I need to get a 0. So we're going to first add an 8 to both sides to 0 out that side. So x cubed minus 2x squared minus 4x plus 8 is less than or equal to 0. Okay, so now to find the x-intercepts, we're going to do some factoring, right? I'm going to factor the first two terms here. Pull out an x squared. I'm using the grouping method here. We'll have an x minus 2 left. And then here I'm going to pull out a minus 4, and that will leave me with an x minus 2 also. And I'm going to then pull out the x minus 2. And I'm going to have left over an x squared minus 4. So we're really looking for where this product is less than or equal to 0. And actually this quadratic is also factorable into x minus 2 and x plus 2. Okay, so if I take x minus 2, notice that these two factors are the same. It's a repeated factor. And so I could write that as x minus 2 squared times x plus 2. That would be the simplest factorization. Now if I'm going to find the x-intercepts, I need to set these factors equal to 0. Okay, so we're going to take x minus 2 equals 0, which leads to x equal 2, and x plus 2 equals 0, which leads to x equal negative 2. And so positive 2 and negative 2 are going to be the two endpoints on my sign chart. So we'll go over here to the side a little bit, put the sign chart up. So I'm going to create a sign chart. Remember, we do an x-axis with the endpoints being the x-intercepts. And separate our interval. And now I'm going to pick some numbers in each of these three regions. I'm going to go with 0 in the middle. That's a nice one. 3 on the right, and maybe we'll go negative 3 on the left. Just three numbers that are in, or one number in each interval. Doesn't matter what number we choose. And I'm going to go back to the factored form, okay, rather than the original, because plugging stuff into this original, this original polynomial here is a little bit tricky with the cubes and the squares. I just like the factored form. To me, makes the arithmetic easier. So I'm going to go with a negative 3 first. Negative 3 minus 2 squared times negative 3 plus 2. Okay, so both of these x's become negative 3. And so then we're going to solve. And really all I need to know is the sign of the answer, positive or negative. Okay, so this is going to be a negative 5. When I square it, I'm going to get positive 25. Here I'm going to get a negative 1, and positive 25 times negative 1. Really, all I need to know is that the answer is negative here. Okay, and so negative answer gives us all negative outputs from negative infinity to negative 2, this entire region. Using the 0, we get 0 minus 2 squared and 0 plus 2. Notice that no matter what's in the parentheses here, when I square it, I'm going to get a positive. And here I'm going to have a positive. And so a positive times a positive is positive, which means everything in that middle interval is positive. And then finally I'm going to plug in the 3. So I get 3 minus 2 squared and 3 plus 2. Again, anything squared is positive. And 3 plus 2 is also positive. And so that gives us all positive outputs on the right as well. Now I'm looking for negative outputs because I want to know where the polynomial is less than 0. Okay, so I want this interval on the left. Negative infinity to negative 2. And so we'll go down here. Negative infinity to negative 2 is the interval I'm looking for. Parenthesis always goes on the negative infinity. The negative 2, however, because it's an x-intercept, the graph touches the x-axis there, and this inequality includes an equal sign, we're going to use a bracket. Okay, the bracket is included when there's an equal sign in the original inequality. That single interval will be the solution to our original polynomial inequality.